This is training on NUCAPS soundings that are available in AWIPS. This training will explain how NUCAPS soundings are created, how to find them in AWIPS, how to use them, and how to modify them. NUCAPS is an acronym, the No Unique Combined Atmospheric Processing System. What is combined here? Infrared data from the cross-track infrared sounder on NOAA 20 and SUMI NPP, and microwave data from the Advanced Technology Microwave Sounder, also on those satellites. NUCAPS is also created with MEDOP A and B, but that data is not available in AWIPS. Over past times, when data are taken for NOAA 20, on the East Coast is around 5Z and 17Z, and on the West Coast around 9Z and 21Z. Those afternoon times are important because that's about the time when convection is starting to fire. So you have a thermodynamic measure of the atmosphere at a meteorologically interesting time. It takes about 60 minutes for NUCAPS data to get into AWIPS from NOAA 20. That's faster than it was with SUMI NPP. If you have a direct broadcast link, it takes even less time, maybe 30 minutes. NUCAPS data were originally created using SUMI NPP data, but the midwave portion of the CRIS failed in late March 2019. Since then, a redundant set of electronics has successfully been implemented on SUMI NPP, so NUCAPS can be created from SUMI NPP now. But NUCAPS from NOAA 20, which is a twin to NPP, are what is flowing into AWIPS now. That started in July of 2019. Vertical profiles are created in a two-step process. First, a regression that uses static coefficients derived from ECMWF output for 4 focus days in 2014 and 2015. That regression is used to create the first guess and cloud clearing field. It uses all sounder and microwave channels. Those coefficients are the statistically most valid for those 4 days. After the regression, a retrieval will minimize the observation minus calculation value. The retrieval uses a subset of channels. It's shape preserving, meaning it adjusts the regression to a solution. The microwave-only retrieval will fail in regions of precipitation. The infrared retrieval can fail in regions of cloudiness. The final sounding computed is on 100 levels that are the standard levels for the radiative transfer model. You can see those 100 levels in AWIPS, and that's really more levels that are warranted by the sounder resolution. For the physical retrieval, only a subset of the CRIS channels are used, 399 of them. 24 for surface temperature, 87 for atmospheric temperature, etc. The channels that are chosen are sensitive to one gas, but not to the other. You would not want a channel sensitive to both water vapor and ozone. You'd want one that's sensitive only to water vapor or sensitive only to ozone. All of the ATMS channels, 22 of them, are used for NUCAPS, for NPP, and for NOAA 20. What is the vertical resolution of NUCAPS profiles? NUCAPS resolves about 9 to 10 vertical levels of water vapor in the entire atmosphere and about 20 vertical levels of temperature in the entire atmosphere. That's shown in these charts of averaging and smoothing kernels. That information is shown more simply in this table. DOF, or degrees of freedom, represents the number of layers that are resolved by NUCAPS data within the troposphere. 6 to 10 layers of temperature, 4 to 6 layers of water vapor. Cloud clearing is an important part of the NUCAPS algorithm. The biggest problem is uniform clouds. Each NUCAPS footprint contains 9 CRIS fields of view. If there is spatial variability to the clouds among the 9 fields of view, NUCAPS will nevertheless produce a good product. But if there are uniform clouds across the 50-kilometer scene in the 9 fields of view, it's more likely to be rejected, even if there aren't a lot of clouds. This shows the 9 fields of regard in CRIS for each NUCAPS sounding. At nadir, they're closely spaced, and toward the limb they are more widely spaced. It's not uncommon for sky conditions to vary across the fields of regard. The sounder fields of regard do not extend to the edge of the swath. In AWIPS, NUCAPS soundings are found under the Satellite tab, then under the SUMI NPP and NOAA 20 part, and then finally you just click on NUCAPS sounding availability. That will bring up an image that looks something like this. The green dots mean that both the infrared and microwave retrievals completed successfully. The yellow dots mean the infrared retrieval failed or cloud clearing failed, and the red dots mean that both the infrared and microwave retrievals failed. I like to plot the points on top of a satellite image so I can anticipate what the sounding will look like. But it's a lot of data. You'll want to enable SKUTs under the Volume tab so you can browse quickly through the many SKUTs that are available. Right-click anywhere in the image to tell what kind of soundings you're going to look at, and turn on sampling. Then when you mouse over the point, the pop-up SKUT will show the profile. This is just another example showing the NUCAPS plotted over a satellite image. Use infrared or visible data like this day-night band. Let's look at these 3 adjacent points and see what they look like. Here are those 3 soundings. The sounding in clear air is very smooth as expected for NUCAPS soundings. It doesn't show much saturation. At the cloud edge, we have maybe closer to saturation in the lower troposphere. The red point in the deep clouds over ocean is a sounding that looks pretty non-physical. Here are 3 adjacent points, green, red, and yellow. The green sounding shown at bottom is smooth and plausible. Both yellow and red soundings have characteristics that should make you doubt their applicability. This shows 4 consecutive passes over the course of one day. North of 40 North, there's an overlap from one pass to the next. There are regions over the southern U.S., small regions that are unsampled. The regions differ from day to day as the orbits shift eastward from one day to the next. If you have consecutive soundings, what does that get you? Here's an example from a convectively active day over Pennsylvania. The earlier sounding is shown in the upper right, and here's the later sounding. There's a bit less stability here. The inversion has weakened, and that's going to inform your decision-making perhaps as the convection over western Pennsylvania moves off to the east. Global coverage also shows the gaps near the equator and the overlap poleward of 40 North. This is for NPP. NOAA 20 coverage would be similar, but if you combine NOAA 20 and NPP, you get no gaps. Why not use soundings from models? Here's a 2-hour HRRR forecast over southeast Colorado. If you wanted to know about the thermodynamics present at that time, wouldn't it be better to use NUCAPS observations that are independent of the model and its, on this day at least, timing problems? NUCAPS profiles have been evaluated at the Hazardous Weather Testbed from 2015 on. Here are some observations from the 2018 experiment, just some comparisons between NUCAPS values and SPC analyses. The forecaster who made these comparisons was very impressed with the NUCAPS soundings. Here are some comments from HWT in 2016. If you go to the website in the center there, at the former GOES-R HWT blog, you can find all entries that are related to NUCAPS. For example, here's a blog post entry from the 2015 HWT, where they took the unmodified NUCAPS with a surface temperature and dew point that didn't really match the nearby METARs, and they modified it, producing something that matched more closely to a special sounding launched at 18Z. Statistics on NUCAPS soundings show that NUCAPS performance is best for moisture versus temperature in the mid-troposphere, where the bias is closest to 0. So look for the best improvement to be between 300 and 700 millibars for moisture. Other statistics comparing to radiosondes also show that best improvement for moisture in the mid-troposphere. To edit NUCAPS soundings so that they agree at the surface with surface observations, you can do a couple of things. First, when you click on the point, note the nearby temperature and dew point. If the surface values of the sounding do not match observations, and that happens in part because the satellite is looking at the surface through a murky atmosphere, when that happens, toggle Edit Graph to On. Draggable points will appear. Move them around. In this case, I've moved the temperature points near the surface. If I don't like what I've done, there's a reset button and you can start over. Once you're satisfied, toggle Edit Graph back to Off. All I changed from the original sounding here was the temperature at the lowest profile, but you'll note that has changed some of the convective parameters, the equilibrium level, and the LCL, for example. Here's a forecast application courtesy of Dan Neatfelt, the Sioux at Omaha. On this day, a broken cumulus field was over western Iowa and eastern Nebraska. The GFS suggested precipitation might fall. Do you think it'll rain? NPP overflew the region shortly before that satellite image on the past page. Let's look at the sounding circled in red. It's a fairly dry sounding with not much CAPE. In addition, its surface values pretty well match the nearby METARs. You wouldn't really have to adjust this. Would you expect convective development? By late in the afternoon, the cumulus field had dissipated. A couple of days later, Omaha experienced severe weather. The image shows two NUCAPS sounding sites at 1849 UTC on June 3rd. Note also the gradient and dew point in the plotted METARs. Let's look at this boxed sounding. This sounding, which was modified so that the surface values were more in line with nearby METARs, has a surface base CAPE of more than 1800. We just looked at the box sounding. Now we're going to look at the one just to the south, which is in clearer air. And remember, there's a dew point gradient there too, so it's probably in deeper moisture. Here we have a zoomed in view. The green box is what we just looked at. The sole red circle is what we're going to look at next. This is the unmodified sounding there. Surface base CAPE is around 700, but the surface temperature and dew point in the sounding do not match the METARs. This was a good sounding to edit. Once the sounding was edited so that its lowest temperature and dew point matched the nearby METARs, surface base CAPE exceeds 3000. This kind of information should influence your interpretation of present conditions and will also guide your warning decisions. Remember that the points that you see in NUCAPS are actually 9 crisp fields of regard, so it's a volume. That's one of the reasons that the soundings are smooth, because you're looking at a volume of air, not the air at one point. Here again is the figure that shows the region that is sampled. The column or volume of air changes in size as you move from nadir out to the edge of the scan. Here are some summarizing points. That's it for this training on NUCAPS. Thanks for listening.